the Structural Engineering Podcast.
Welcome back to the Structural Engineering Podcast. Today we're stepping outside the world of beams and loads to talk about something just as interesting and wrapped in the backdrop of structural engineering. That's innovation in tools available and entrepreneurship in making the changes needed. Our guests, Nick and Peter, are the founders of CalcBook, a platform designed to bring clarity and professionalism to the way engineers document calculations.
In this episode, we'll dive into how ideas came to life, what it takes to build a business in a technical field, and how CalcBook is helping engineers. Whether you're curious about launching your own product or just want a better way to organize your design, this episode is for you. Now let's get into the episode.
So my name is Peter Jacobs. I am an engineer based out in California, kind of in the just outside San Francisco. Been working in the industry for about 15 years now. I used to work for a large corporate company and doing structural engineering, and kind of worked my way up started out as an intern, and then worked my way up from there. And then now about 2 years ago, broke off and started my own design firm. And then also, we'll get deep into it, but a few years back also started CalcBook with Nick. So that's kind of where I'm at today.
And I'm Nick Treadaway. I'm also originally from California and lived there most of my life, but the last 7-ish years I've been living in Denmark over in Europe. I have some building engineering experience and some also experience working on sort of light rail train systems, structures for those. And then the majority of my experience has recently been working on offshore wind farms, and I've been practicing structural engineering, graduated a little more than 10 years ago.
Fantastic. We're excited to have both of you guys here. So we're here to talk about CalcBook, the business both of you started a few years ago. Could you start by telling us what CalcBook is and how the idea first came to be?
Yeah, I mean, I think, like a lot of ideas, right, it came out of our sort of frustrations and experiences working in the industry. So Nick and I, worked together a while back, and, we were, young engineers, working on a lot of calculations and dealing with, a lot of Excel templates and MathCAD templates and, using some of the other software out there. And we just kind of were not happy with what the programs were giving us, or having to take a bunch of time to create spreadsheets or revise somebody else's spreadsheets, right, or something like that. And so experiencing a lot of those pain points firsthand, I think, is sort of what led us to think, okay, I think there's a better way to do this, especially from a young engineer's perspective of how, what do I want out of a professional calculation software? And that's sort of what led us to start CalcBook. So CalcBook is really, it's a structural engineering calculation platform that delivers, the most detailed, transparent, and easy to follow calculations that we think is available on the market. And unlike a lot of the other tools out there that sort of feel like black boxes, you really don't know what they're doing inside. You're just getting an answer. We really focused on showing every step of the calculation super clearly, so you actually understand what the program is doing, and kind of gives you that confidence in your calculations that you're producing.
When did you decide to go from this idea into making this an actual business?
There was probably no one single defining moment. I think from the get-go, when we started building something, there's always, that thing in the back of your mind that kind of keeps you going. That's like, this, there might be something here. We should keep pursuing this, and there might be a way to actually, make some money on this or something like that, and actually build a program, and be something that we're proud of. And so I think that's always there, and you just kind of, it's such a long, drawn out process, right? And it's not just one specific moment where you go, okay, now this is a business. We kind of start with a prototype. We show that to a few people. They thought it was interesting, and they're like, okay, what's the next step? So, there was definitely a couple points early on when we showed the prototype to, more than one or two people, and some people that we really respected. And they kind of said, hey, this is really interesting, right? You guys are approaching this from a totally different angle than what's out there right now. And I think if I had to pick a defining moment, it's probably talking to those, really senior people that we really respected. And we said, okay, let's take a step back here and try to figure out how we're going to actually turn this into a business from what was at that point, an Excel Visual Basic program that we were using as a prototype. So getting that feedback, from a really person that we respected, that I think was a defining moment.
It's great to get feedback like that. I mean, that would really push me.
I'm not a programmer, but sometimes, you make an Excel calculator and you think this is really nice. And, you step back, someone to look at it like, this is actually not that good. But I've used your software and it's so nice to have the output just tell you all of the equations. So I'm glad that you made the step into launching this.
Exactly. Like you oftentimes will build a spreadsheet and you're like, oh, this is great. And, I want to, do something with this, but then you realize like, oh man, but what about this situation or what about this edge case? And like to actually go from that prototype into something that, and we'll talk about this, I'm sure later about all the edge cases and how you deal with that. But, making that jump is a big one. But, we had enough in the prototype for people to realize what it could be. And so I think that really helped us, kind of push over the edge and go, okay, let's do something about this.
So something that comes to mind is like you guys have to have some background of way more than just structural engineering, entrepreneurship, maybe some coding. Like what background helped maybe shape or experiences you had help shape and build what you have now?
I think both of us, Peter can chime in later on his experience, but I think both of us had some prior knowledge with Visual Basic in Excel, which is a terrible language now that I've gained more experience coding in a proper sort of framework and interface. But like my first job, for example, I was one of the only structural engineers at that job. It was a rail systems job, so it was a lot of mechanical and electrical people. And I sort of was tasked with making these little tools of how to design base plates or bolts or whatever, where these mechanical guys had just been like doing a best guess and Googling how to design a bolt or something. So I think that definitely shaped my path to CalcBook in that like I was almost doing like a very rudimentary version of it for this hyper specific application at my first job, just because there was no other tools available to design what I was designing at the time. And then I joined a separate company where Peter was also working, where we were doing buildings. And I think there was some Visual Basic coding there. Maybe you can speak a little bit better to that setup, Peter.
Yeah, I mean, I think also taking like one step back, similar to Nick, when I was in undergrad, we had a professor who had built a program out of Visual Basic and like a professional program out of Visual Basic, like way back in like the 80s or something. But he spent it wasn't like, maybe a third of the semester or a quarter of the semester teaching us how to use VBA. And then we like created a finite element, program in VBA and doing, matrix multiplication analysis and all that. So when I sort of saw the power of programming and combining that with structural engineering, I thought that was just a really cool, different angle of structural engineering that I hadn't really seen during college. So I think that kind of stayed with me. And then, like Nick said, when we kind of we met each other at the company we were working together, we kind of both realized we had this passion for VBA. And so I think that was part of it. And then Zach, you mentioned like entrepreneurship on the other side of it. I grew up in the Bay Area, which is, Silicon Valley, Mecca, and, was in high school when Facebook came out and then the iPhone and all of that. So, I was just surrounded by, everybody seemed to have a company and was getting venture capital money and, making millions. And that was sort of the Silicon Valley tale, right? So I think that was always there as well as the business side of things, and wanting to sort of have that Silicon Valley startup success story, right? And you start this thing because you think it's cool, and then people like it, and then you kind of go from there. So I think that also was a big part of the business side of like kind of going from this is just a fun prototype and actually going into making it a business.
We're really excited about the episode today, and we've got two announcements we want to share quickly.
Now, to start off, I know we all get those emails.
I don't check my emails. What do you mean?
Okay, come on, Max. Well, NCSEA does a survey every year about pay, vacation, benefits in general. I'm sure you've seen this, and we all kind of want to be more informed, and having that data really helps our decisions.
I think the field should be receiving fair and increased pay, and it's very hard to put a number to that when we don't have the full picture.
Yeah, that makes sense. But historically, NCSEA has only gotten a small percentage of engineers to even fill out this form about benefits and pay that they want to share with people.
It takes 10 minutes. It can completely push the industry in a better direction. I know.
I think it's something we need to provide. So if you're listening to this right now, please check out the link in the show notes. Send it to everyone you got. I mean, Max and I are going to send it to all of our colleagues and definitely close coworkers. I think we can change the trend of this small fraction of the industry that's responding now into something a lot bigger.
I've got a few emails from people that have sent us stuff. I might send it to them too.
I think it's a great idea.
All right. The next announcement, one that's closer to me and Zach.
So this is something Max and I are both super excited about. We've been working on for quite a while, and we're excited for you guys to help out with this as well. So if you're looking at leveling up your game for PE, even your FE, your SE, or just your knowledge about structural engineering, we might have something for you. Max, is that something like you might be interested in?
Interesting, Zach. That is something I'd be interested in.
Well, that's great because we built it together. So if this is something you're interested in, check out Structure Ed. It's the ultimate study tool. It's built by and for structural engineers. We designed Structure Ed to be fully powered by community-driven question bank. So we're learning along our peers, and we can share the journey together. The app is an interface where you can answer questions, but also provide questions as you suggest them that we can use.
Yeah, and this is fully free. It always will be. And we think the structural community can make something really amazing to help everybody study for the tests we all take. You know, if you're an expert in slab design and concrete, throw 10 questions up that you always see incorrect. People will learn from this and include their own.
So it's really easy. Follow the link down in the show notes. You can create your free account today and really start studying for either that exam or just to become a better structural engineer. The website is theengineeringpodcast.com/structured. STRUCTURED. Structured.
Isn't that a / if it goes to the right?
/ everything /
Let's go to our website.
Sweet.
I'm curious, when you guys started going down this route, was it to make the work you were doing more efficient, or was it always that you were going to start a business with this?
I don't know what you think, Nick, but it was definitely both, right? I mean, I think there was parts of it, like one of the big things, or one of the things I was doing when we kind of thought about creating a program is I was doing some like beam clamp on a flange, and there was loads, and I had to go to some obscure part of, AISC to find the distance of the flange and all this stuff. And I was like, why is this not just in the program somewhere that I can just go a few drop downs, select my things, and just be done with it? And also have all the, the steps shown out so I know what it's actually doing and all the references. And so I think that was definitely, one side of it. And then obviously the business side too was a big pusher. But yeah, Nick, I don't know what you think there.
Yeah, I think the business was always like the sort of white whale that we were dreaming of, but it was such a long path between making like a simple tension calc proof of concept to sending formation documents to the state of California that I don't know. It was never front of mind of we've got to start the business right now. It was more, for better or worse, we really wanted to have the product in place first, and that was just such a grind, for lack of a better word.
Yeah.
So I think it was always in the back of our minds, but it wasn't forward in our actions as much as the development process came much later than maybe would have been nice.
Yeah, and I think just to add to that, if this was purely about the business, I think we would have stopped a long time ago, right? Because it was such a long road, because this was a second job, right? This was nights and weekends. It wasn't our primary thing. So just the pace of development, that took a lot of passion, right? If it was purely about the money and, we had taken out loans or whatever, it probably would have not succeeded. So I think that was actually to our benefit, sort of the slow pace, and we just enjoyed doing it. I mean, it was something that we both enjoyed doing, and seeing the progress and seeing the, kind of the steps that we were making along the way.
Yeah, you just said Silicon Valley, so I'm just thinking venture capital, wild times, So.
We did actually have one meeting with the venture capital guy. I don't know if Nick, you remember this, but it was in San Francisco, and we went and we kind of did our pitch a little bit, and it was venture capital is sort of a family friend, so he was kind of doing us a solid, listening to us. And we had this whole pitch deck put together, and it didn't feel right. We were like, okay, well, we'd have to quit our jobs and do this, and we'd have to take on this money, and then we have this big responsibility. And there's pros and cons to that, right? And so, but I think we just sort of decided, okay, this is not the direction we want to go. We just want to bootstrap it and kind of build it ourselves, and that's the direction we went.
We're structural engineers. We like to err on the side of conservatism. So
Exactly.
Yeah, I was actually just meeting with a a person out in the Northwest that was saying like there's so much venture capital money going into engineering right now to buy up firms, and I'm curious to dive into myself, but to understand like why is all of a sudden venture capital coming into the engineering world to grow it? Like there's got to be something to that, because there's got to be a payday at the end of it. So
I mean, I think
all an interesting world.
Yeah, I mean, I think, as we can all admit that I think structural engineers in particular are pretty against change and, being, on the forefront, right? We like our spreadsheets and our templates, and we like, going into the book and doing that stuff. So I think there's just opportunity for advancement in the engineering world. So there's probably some of that as well, I think.
Absolutely, which actually leads to my next question very well is, what gap in the industry were you trying to fill? Structural engineers are not great at making changes, but we're kind of lagging as an industry. So yeah, what was the target?
From the calculation side of things, right, which is where, is kind of our specialty for CalcBook. The gap on that side of things was really focused on this black box software, right? And so, the software that was out there, and, we've all used them, it just did not deliver the product that we wanted. And so we felt that we were spending a lot of time doing side calcs, hand calcs, trying to understand what these programs were doing, trying to have some level of confidence in them. And then you put in some inputs and it doesn't work. It gives you an error and you don't know why, and you can't really diagnose what's going on. And so, from talking with other engineers, we felt that was a true need for engineers to have that level of confidence in their calculations and be able to dig in, to the software in an easy way and have a clear output and be able to figure out what's going on and really understand the calculations. So that was really the goal there, was trying to provide that modern, clean structural calculation software, to quote unquote bring us out of the 80s from when a lot of these products were developed in, the 80s, 90s, that sort of thing. So that's really from the structural calculation side of the industry. That's what we were really trying to do.
And so I know you kind of brought it up maybe a little bit, but was there a particular moment or project that made you realize there's got to be something better? There's got to be a better way to do this.
From my memory, Peter and I had previously discussed frustrations with software like he had mentioned, but I can remember one time where I was designing, I think, some collector member, and I had this Excel template or MathCAD template. I can't remember clearly, but it reminded me of when you said earlier, Max, like you have this calculation, and I inherited it, and then I, spruced it up a little, and I was so proud. All right, I got this wide flange design template ready to go. And then it like had a slender flange or slender web or something, and I was like, oh no, it's suddenly this calculation that I thought I had nailed down is no longer useful here. And then I was just like, I think, Peter was a little senior to me, and I went over and was like, do I got to just build this up again from scratch or whatever? And he's like, yeah, basically, welcome to the show. And I think that helped lead into like, there's got to be a better way conversation. I don't know if you had anything in particular, Peter, that you remember.
One of the ones I already mentioned was like doing the beam clamp hanging from the beam flange and trying to tackle that. But there's a lot of those types of sort of oddball equations in AISC, like, like chapter K calculations or something, where you're doing like an HSS plate or something like that into or a plate into an HSS. And like you said, it's like, this is not an overly complicated calculation, but there's just a lot of nuance to it, and you got to go find the right dimensions and the right different properties and kind of make sure you understand all that. And it just seems so ripe to have an easy software to do this, directly from the book. And I think that was sort of an aha moment of like, okay, this should be somewhere in a nice software that everybody can use. So yeah, I think, is that, along with, I'm sure, a lot of other, Nick said, frustrating existing Excel templates, and having to modify them and not having them ever work perfectly, but just good enough to move on to the next thing. So yeah, there's a lot of that as well.
Yeah, something I was just thinking about that I really like with this too, like you're saying, it kind of shows everything it's doing, is a lot of work that I've done in the Northwest, California, Oregon, Washington. Those AHJs are really strict. And when you send them something in Excel, they're like, hey, can you just provide a quick hand calc showing this works? And then, blah, blah, blah. So have you guys seen the value in just that? Like the AHJs now have access to really understanding what is happening instead of a Excel sheet maybe that's kind of hidden.
That's a great point. And, along with the HJs, I'm sure, the companies that you guys have worked for, have their own internal QA, QC processes. And so being able to not only speed that process up from the engineer side, but the AHJ or whoever is reviewing it, they can beat up their review process and also be able to see all that stuff. So there's definitely a lot of value there. And I think, being able to turn around those quick calculations is a lot easier with CalcBook for sure. And we have what we call standalone calcs, alongside member design. So we have like welds and different sort of pre-set up little design modules to help with those quick calcs to turn things around, like doing a quick weld or doing a quick bolt check or something like that, where you don't have to take the time to set up a spreadsheet. So yeah, we've definitely noticed that. And actually, one of the things that we just started doing recently was giving free licenses to AHJ reviewers. So they can actually have it, on their side of things, so that they can, instead of making a comment and having to go back and forth 4 or 5 times or whatever, they can do a quick check and go, okay, yeah, this is reasonable, or whatever they needed to use it for. So we just started doing that, and we've already seen quite a few people reach out to us for free licenses as reviewers.
Dang, that's pretty awesome. Yeah, I'm thinking back to like as you say that them running quick checks and stuff. I now work kind of more in the Midwest, and an AHJ that wants your drawings is surprising, let alone calculations. So it's always interesting. But I've done some projects when I worked out there for Oshpod, which I know has been rebranded, but that's how I know them. And they would do their own calcs and send me calcs back and give me comments. And they're like, "Hey, that footing could be smaller," and I'm like, why would you, what? That's weird. They're like, "Oh, I ran my own calcs. Here, review these." So I get that AHJ part. That makes a lot of sense and a great idea. Yeah, I'm so curious on this because Max and I find this all the time as we're like doing the podcast, and we now do this weekly trivia that we send out, and we're putting together some other things that we're excited to come out with soon. But like, by doing this, how much better do you feel like you guys have become as engineers? Like, how much better do you feel like the code and the depths of it?
Personally, I feel like I'm like ready to call myself an expert on the steel code, at least. Like, if anyone at my work comes with a question, I mean, I'm in Europe, so they're also not experts at the American steel code. We typically use Eurocode, but if they have any question about Eurocode, I'm like, let's go, bring it. I've like looked through this thing front to back so many times. So it's definitely helped me a big time. And mainly I use steel now, but even in my professional life, I mean, outside of CalcBook, but like also, I mean, I've got a good understanding of concrete and timber as well now after building out those modules. So it's helped a lot, I think.
Yeah. And I mean, like Nick said, at this point, I can pretty much think, off the top of my head, the different sections in the NDS of where I need to find whatever sort of specification or, bolt size or lag screw or whatever. Yeah, I know too much about that code now, which is great. It's great for my professional career. But yeah, it's definitely taken us into that second layer, or third or fourth layer of engineering, where sometimes you're just scratching the surface just to get the calculation done and get it out the door and make sure it works. But when we're programming it and trying to capture all the different edge cases, you really have to think, how are all these engineers going to use the program, and what sort of things are they going to do, and how are they going to enter inputs, and what sort of path is that going to lead them down in the code. And so, we really start to understand sort of how, I don't want to say theory, but sort of more of the theory of the code and how things are put together. And you're kind of going to that second or third layer of calculations for sure.
Yeah, you can't really leave any path unturned. So you sort of actually have to go down every single route that is possible of permutations of what sort of inputs could be put in. And I mean, yeah, we've had long conversations about user notes or, commentary in the spec and how to interpret it. We've also reached out to like AISC's technical team. I know many times. Shout out to them. They're quite helpful at answering very niche technical questions.
Very specific in a little corner of a code. Yeah.
Totally. And sometimes it takes like a week or two for them to find the guy who can answer that question, it seems like. But they're always good at getting back and actually providing a legitimate answer, though. Yeah.
Yeah. And the actual funny story about that is we were doing a bolt design module, and there was one of their AIC, I don't know what they call them, not like a white paper, like a 2 or 3 page sort of technical memo. And it was called The Tale of Tearouts, I think. And it was talking about bolt tear out and all this other stuff. And I was going through it and, doing my examples and building the program for that. And I had a question on it. So I reached out to the AISE line and I was like, hey, I was looking at Tale of Tearouts, I had these questions. And I finally get a response like a week later. And it was the guy who wrote the article who had responded to me. And it was great. And so we had a back and forth and I was asking him a bunch of questions. And so yeah, the technical help from AISE is actually really, really good. So if you ever have questions about the code, they will they will find the right person to talk to you about it. So
after this episode, we're going to have to figure out all the people there you talk to that you think we should have on the podcast, because that sounds phenomenal. Like, these sound like the right people we want to talk to.
And the one other thing I'll just mention is that Nick was saying, we have to go down all these different paths to try to figure out, make sure we capture all these edge cases. And then we think we get everything. And then we go, okay, this module is ready to go out, and we'll publish the module. And then sure enough, within like a week or two, we'll get somebody said, hey, I entered this and it gave me an error. Like, what's going on here? And we're like, oh, we didn't even think of that. Like, how did you even get to this answer? So it's humbling for sure when you think you've gotten everything right, and then within a very short amount of time, someone points out something probably pretty obvious. So
I want to get into building the product. I want to get into building the product, right? This is going to be a great idea. You have some great concepts that people have. Have you spoken to them about it? How did you go from concept to first prototype? And more specifically, I wonder about the programming. Like, how did the programming go, and how much language did you have to learn to be comfortable there?
I mean, it was sort of an interesting progression, actually. As we mentioned a couple times, right? We did the first prototype in VBA, and so Nick and I wrote that on our own, and that was enough to sort of get something to show up on a screen and click through some buttons and show some stuff. After that, we actually reached out to Cal Poly. So that's where Nick graduated from Cal Poly. And we reached out to their computer science team, I think. Is that right, Nick? The computer science division. And they do these senior projects where they bring in outside companies to sort of pitch their idea or their product or whatever to the different groups in the class. And then they take it on as a semester project. So I actually went down to Cal Poly. I pitched the idea to them. And so I had 5 computer science seniors, I think, that we worked with to develop it. And Nick, do you know what language they programmed it in?
I think that was in C#.
Okay. So they built the sort of, call it the second prototype in C#. And that was actually a great learning experience for us as well, because it kind of taught us how to communicate with non-structural engineers, right, about how to put together a program. So that was a good learning experience for us as well.
I would also say, for that senior project, capstone project at Cal Poly, we were pretty hands off as far as the actual coding. So it was a lot of like sort of Peter mentioned, like having to translate structural engineering to these computer science students, which was definitely a challenge and something I think we improved in the next iteration, which you can go ahead with, Peter.
Yeah. So once we did the Cal Poly project, that gave us sort of a better, prototype to show to people. And then we got serious about it, and that's when we brought on a developer. So we brought on a really, really good developer that I know from college. And that's when sort of the real programming started. And so, yeah, CalcBook is built using TypeScript, which is sort of, as I understand it, and again, this is a little bit outside my area of expertise here, but it's basically built on top of JavaScript. And then we sort of build the whole program on top of something called Electron, which is, I think Slack is built on Electron, and a few other programs, but it's more or less a sort of packaged up version of Google Chrome. So it kind of looks and feels like that, and has, it kind of, you just use that as sort of the base for building everything. And then we use React components to do all the UI development, and then we use like an open source free component website called Evergreen, and that's sort of where we get all of our type and all of our different objects and icons and all that sort of stuff gets imported from Evergreen. So that's sort of how we build everything from that. And then sort of one level deeper into that, right? We have sort of what we call two sides to the CalcBook development, right? We sort of have the back end, really heavy, development architecture stuff, which Nick and I don't touch for the most part because we'll likely mess it up, right? That's what's our developer deals with. And then we have sort of like the structural engineering and front end and user interface stuff, which we do a lot of work in. So our developers sort of built a lot of really good tools for us to develop. So we have like things called equations, right? Which is pretty obvious what that is. And then we have like free parameters, which is like an input, and we can have drop down menus or checkboxes. And then we have a thing called a dynamic equation, right? Which allows us to sort of make a decision, right? If you're looking at like a compression member or something and you have, equation 4-3 or 4-4 based on some other thing, right? You'd run that through a dynamic equation and it would kind of figure out the logic, and then you would, route to one of those equations based on that. And so he built us a lot of great tools that we can basically run with. And from there, we pretty much been able to develop whatever we needed. Every once in a while we have to create a new tool, or he creates a new tool for us. But using the equation, the dynamic equation, we have the images. We're coming out with something new called an active image, which is, basically has, live updating dimensions and diagrams and all that sort of stuff, which we're really excited about. But yeah, that's sort of the kind of the high level, architecture of how we built CalcBook. Yeah.
That's so cool. It sounds like a very technical problem to solve, which is the best kind, of course. What were some of the biggest technical challenge you guys were seeing early on in the development?
I think the biggest thing looking back is, Nick and I just wanted to build it. We were like, let's just build equations, let's build calcs, and then we'll just repeat that process and we'll have this great product. But, looking back now, I think we should have spent more time on thinking about the entire framework and how our future calc is going to be implemented, how our future versions of code, a building code is going to be implemented. How are we going to track that? How are we going to, run a member design, which has like multiple parts to it of compression and flexure, and then we have to do combine loading. So, that entire framework of how the program is put together, I wish we had spent more time on that at the beginning, because I think not halfway through, but, about a year in or so, we sort of realized that what we were doing wasn't working. And so we actually had to basically rewrite a large portion of the back end of the program to be much more accommodating to, these different types of calculations that we wanted to perform. And actually, I'll credit Nick with this, and he can talk about it a little bit, but Nick spent a bunch of time creating this white paper, which we still use today, which outlines everything from user input to demand capacity ratio and all of the different possible paths of like, okay, if you have, this input and this equation, and you have these different load combinations, or you have multiple different failure modes, you could have bolt shear and you have row tear out. It's like, okay, how does that all fit together and come down to one demand capacity ratio? So yeah, Nick, I don't know if you want to touch on the white paper, because that was a huge thing for us to come up with.
I think making that sort of bridge the gap of what our developer was hounding us to try and figure out for a long time. And we're like, yeah, let's just build the calcs and like, come on, let's go. We're anxious. We've been doing this for a while. And I mean, it's almost like speaking a different language, talking to a software developer sometimes. Like he's very abstract and like waxing poetic about like big picture of how this thing should work. But then when we finally like kind of understood what he was talking about and like really laying it out, on paper helped, where you're actually showing, okay, here's where all the load combinations will get set through. Because, if you're checking like 5 different failure modes and you're checking for every load combination, then there's like a lot of, loops going on in the background, and like, where do those run and in what order should they run? Should the load combos run first? And then you check the failure modes, or we've got different phi and omega factors, and so sort of just like putting that out on paper and showing like, do this step 1, then take these inputs and combine with this step 2, and having it sort of as a graphical like flow chart was really what was able to communicate to him how this should work. Because I think also we're probably victims of just like assuming like it's obvious to a non-structural engineer when it's really far from it. And, something we've probably tried to explain poorly 7 times might still not click with someone with no structural engineering experience, which is more than fair. So like really breaking it down in granular detail and in very like not so granular where it's specific to one calc, but keeping it global to like, okay, and then we can apply this framework to every single calc moving forward. And being able to crack that nut was sort of the key to doing a bit of a architecture redesign on the program that really unlocked like the scalability of the program. That definitely, I'm happy it didn't happen later, but it would have been nice to happen sooner. But we got there, and it was a huge learning process for Peter and I know.
Yeah, it sounds like you didn't shy away from the intricacies. Like building software is very complicated. How did you guys balance the complexity of code and then flexibility when designing tools for engineers to just use every day without sort of a training required, a helpful tool?
Yeah, I mean, I think we sort of talked about this a little bit, but the edge cases of calculations can be, there's many different edge cases, right? And so if you were to try to program every single edge case possible, the program would just be cumbersome, right? And it would be, wouldn't be able to be usable, and it would be super complicated. But on the other end of that spectrum, we're engineers. We want detail, we want flexibility, we want to be able to have a lot of choice in the calculations that we're doing. So we do what we kind of started ourselves is we just call it the 80-20 rule. So we just try to program for 80%. So if there's some edge case, some oddball case that we think only 20% of engineers are going to use, we just kind of say, okay, we're not going to deal with this right now. This will be a future update maybe, but we want to kind of stick in that 80% realm of sort of the level of detail or the level of complexity that we're implementing into the program.
Yeah, absolutely.
Okay, well, moving into business, which is something I find so fascinating as a structural engineer. How did you guys decide on the name CalcBook? And then what were the first few months like after you launched your business?
Yeah, I mean, the name, we had a lot of awful names before we came with CalcBook. And I'm not sure how long it took before we came up with CalcBook, but yeah, we had a bunch of different names that we were just using in the interim. We actually tried to look up the other day some of the old ones. We couldn't find any of the old ones. But anyways,
you remember the worst one or something?
I hope it was something like Peter and Nick's best spreadsheets ever that anyone could ever use.
Version 3 final. No, really version final. It's some long name. No, but yeah, I mean, CalcBook, right? Everybody knows that term, right? It's like, okay, you have the drawings and you're putting together a CalcBook or the calculation book, right? And so we just thought it was a really common term that would be easy to remember for structural engineers, and something that sort of resonated, like, okay, yeah, I'm putting together this CalcBook for this project. And so it was something simple. The URL was not outrageously expensive, although it was a lot of money to us at the time. But it was the URL was available. It was relatively cheap. And it was just sort of a simple name. And something that we thought engineers would recognize pretty easily.
And then what were the first few months like after you guys launched?
Yeah. I mean, we released it and we went, oh, this is going to be great. Everyone's going to buy it. This is going to be awesome. And it was just silence. I mean, I think it took us like 4 or 5 months before we got our first sale. It was pretty humbling. I mean, we just thought we had built this great thing. We had talked to all these people, and we had done these sort of beta tests with groups of people, and everyone really liked it. And we were just like, oh, this is gonna be, this is gonna take off right away. And that was not the case at all. So it was rough for sure. And then it was like, okay, now we got another one, and then we got another one, and then you kind of keep building on that and just kind of going. But yeah, when it first came out, man, that was a rough sort of realization that this was going to be a lot harder than we thought. So
any, I guess, lessons learned there from like a marketing standpoint? Pretty much all of our audience are engineers, so they have no clue about marketing or probably not business very well either. So like, what have you guys learned about marketing and how important that is?
Well, first off, a little bit, it's kind of related to marketing, but I think like a mistake that we made there was like learning that perfect is the enemy of good as far as developing. And like we spent way too much time deep in the rabbit hole of the AISC code on like edge cases that maybe to this day no one has hit, or very few people have hit. And we could have like saved probably 6 months to a year if we just like decided we're not going to cover that for now. And then we could have started the whole marketing, efforts sooner, and like wrapped up those edge cases in the meantime, because I think we spent more time sort of underground and not advertising it than we could have for cases that are not make or break use cases for people. So I think like just time, you hear with like investing also, like time in the market is worth something. And I think it's the same thing for marketing, especially in the digital age where things just sort of percolate online. And, we have YouTube videos and LinkedIn posts and stuff, and then someone will see it and maybe mention it to a colleague. And that sort of, word of mouth marketing also just is a function of time, basically. But I mean, other lessons learned we had was like, all this, we are not marketing people by any means. So like huge learning curve as far as learning to, I mean, even things as simple as setting up a website and like it's not marketing, but getting payment processors and like, issuing license keys and figuring out how to post on social media. We're not big social media people, generally speaking. And, just this whole new world where, I mean, we got a lot of outside help from family, friends, or we've got a sales advisor now who helps with like cold sales outreach, which is also a very unnatural, thing to just try and call up engineers and sell them on stuff. But then, you talk to a sales guy and he's doing that 8 hours a day, and you're like, wow, what a different world we're living in. So I think, the whole experience has been very humbling from the non-engineering side of stuff, learning how much we don't know in that world and how deep the marketing and sales worlds can be. Yeah, I don't know if you have anything to add on that, Peter.
Yeah, I mean, the only thing is just sort of what you already said, but looking back, right, like building the product, building CalcBook was the easy part, right? I mean, that was, for us, that was fun. It was easy. We could do it. We knew exactly sort of where we were going with it. And the marketing and sales and all the other non sort of engineering development stuff was just like, what are we doing? We have no idea what we're doing. And it was just, I mean, it was frustrating for sure, like trying to figure this out and trying to navigate this, and some things worked, some things didn't work. And so just trying to figure out that process, and we're still figuring out that process. That was just kind of, the product was easy, and the marketing and stuff, that was tough.
Yeah, I think one more learning curve that we had also is like, you get so invested in this program that you spent years building, and you reach out for feedback from family and friends who are maybe being polite and like, yeah, it's great or whatever. And then you release it and you're trying to sell it, and you just realize like people are busy. Maybe it's a good product and they can find it helpful, but they're too busy to deal with it today. Or like you kind of just got to bang your head on the marketing and sales side of things over and over. And it's brutal. You got to swallow some humble pie and just like keep at it. And eventually, like we've seen it start to pay off, and, it's nice reaping some rewards from it, but it's definitely a different world, and you definitely have to, eat it a lot and just live with that and learn that. I mean, I just thought so many people would be so interested all the time. They're like, I can't deal with this today. Like, I got a deadline, and I mean, you guys get it. When you're busy, and like, sorry, I can't afford time to look at your little project here. So that's been like pretty eye-opening for me, I think.
Yeah, Max and I ran into a similar thing with the podcast. We started in 2018. We we recorded on a cell phone. It was horrible audio. The first like 7 episodes, the content's not bad, but man, the audio sucks. And we still to this day get like emails like, hey, I would listen to more of your podcast. The audio didn't suck. And I'm like, what did you listen to? And they're like, episodes 1 through 3. I'm like, start at 10 maybe and move on, or start at the newer ones. It's gotten better. Like, and then the next email will be like, you guys are the best. We love the podcast. Please keep it up. Like, you've changed my whole career. And we're like, hold on, do we suck or did we just change someone's life? We totally understand that. Like it is just going out there and doing anything different from anyone else, right? And it's just drives challenge. But yeah, I'll forward Max an email and be like, man, we just convinced this guy apparently to join the industry, and he went to engineering school because he listened to the podcast, and it's like, that's so cool. And then the next person's like, you guys suck. It's like, okay, all right,
Yeah.
cool.
Take the good with the bad.
We've definitely gotten some emails like that too. Like, oh, I don't need this. I have this program or whatever. And then, we get other ones like, oh my gosh, this is so amazing. We love this. And so, yeah, we totally understand that.
So I'm curious. And so looking at your guys' website, you have three kind of options, let's say three big categories: the professional, the classroom, and the student. Can you break down kind of your approaches with those three and how you came up with that, I guess?
Yeah, I mean, it actually kind of goes back to our first customer. So our first customer was actually a professor at Ole Miss who wanted to use CalcBook as an instructional aid. He just liked how like the calculations were laid out, and he could really kind of use it as he was teaching. Because we just came out with steel design was the first module we came out with, and so he wanted to use it for his steel class. And so that was something that had never crossed our mind ever was using it for academic purposes. But then we started reaching out to other schools and professors, and so they actually found it quite interesting. And we have now a fair amount of schools that use it either in their lab settings or they hand out licenses to their steel students or timber students or whatever during the semester. Or they use it themselves for instructional aids. So that was like never on our radar, and they're like, oh, this actually makes sense. And so that's sort of how the academic license came up, and then the student license came up. There's a fine line between sort of cheating, I guess I'll say, right, and using it for help. And I think that CalcBook can be extremely useful for people trying to understand how things are done. It's all about how you use the program, and so we felt that putting a student license behind a paywall would prevent that sort of just, I'm just going to use this to do my homework and be done with it. So it's discounted very heavily for students, but having that paywall makes it more of a legitimate purpose, right, and use it for their studies, use it to help them study for homework or for tests or whatever it is. So that's sort of how we came up with the three different design or different modules.
Yeah, no, that makes a lot of sense.
I would also say for the professional side, I mean, that was the idea originally, like, yeah, and then we'll just sell, tons of licenses to huge consulting companies and like, boom, we're good. But I think an interesting thing that we've run into is these big companies have a lot of inertia and are big and slow. And, I would say much more of our professional licenses are going to like small to medium-sized businesses because, some decision maker there who's actually an engineer is able to pull that trigger without going through a whole procurement process and involving IT and et cetera, et cetera. So that's also been interesting that like, also on the note of the Ole Miss guy customer is like sometimes the customers that you don't expect just sort of find you. And like not everything goes to plan there, and you kind of just got to adapt and go with the flow. And yeah, it's been interesting in that way also.
So yes, still sticking on this business thing. I've always wondered how this works, but how does like the liability of software like for what we do? Because what we do is life safety, right? If we mess something up, that's a really big deal. So how does the liability work for you guys if you're open to discussing and sharing that? So I'm so curious, like when we design something in Bentley and it maybe there's a software glitch, who's responsible for that at the end of the day from a legal standpoint?
Yeah, you can talk to our lawyer.
Yeah, we'll refer you to our lawyer on that one. No, I mean it's a great question, right? I mean it's a super good question, we thought about this obviously at the beginning, and we hired a lawyer and asked that specific question. And at the end of the day, it's the professional responsibility of the engineer, the responsible in charge engineer to make sure that whatever they are stamping and signing is accurate and is meets or exceeds the code. And so if you read in our website, deep in the legal, disclaimers, right? When you download the software, right, you are, abiding by that basically. And so it's a pretty boilerplate, disclaimer that I'm sure if you look into any of the other softwares out there, they probably have a very similar statement. That doesn't mean that someone wouldn't try to sue us. I mean, I think I've heard stories of people suing, SAP or whoever else. I mean, I'm sure it happens all the time because when there's a lawsuit, they try to drag everybody down, right? So, and our lawyer told us that too. She said, this is the best we can do. We can, have them basically accept this agreement, but definitely doesn't preclude you from getting sued. But this definitely puts them on notice that at the end of the day, it's if you're signing and stamping those drawings and those calcs, it's your responsibility. As it should be, right? I mean, that's how it is when I stamp and sign things. I'm not just blindly submitting stuff, right? If I'm responsible in charge, I'm looking through all those documents and making sure that I feel good about putting my name on it before it goes out.
Yeah. I want to go a little back towards the software here, that it's really hard with the momentum in engineering. Is people just use this software, and even if you provide a better software, it's kind of hard to throw people off to be willing to try something new. How have you approached growing the user base? Is this mostly word of mouth within the engineering community?
Yeah, I mean, yes, it is mostly word of mouth in the sense that, like you said, and Nick said this earlier. People are busy. They have deadlines. They don't have time to switch, right? And so what we try to do a lot is we try to provide a lot of sort of informational content or useful content, right? So like we do these YouTube tutorial videos where we're doing designs and we're using CalcBook in the designs. And so sort of our user story, is oftentimes an engineer is struggling with a problem. They're Googling it, right? Or using ChatGPT, I guess nowadays. But in any event, right, they come across either one of our blog posts or one of our YouTube videos or something that's actually useful to them, right? And so having that warm lead, right, they're the ones that find us. They come to our website, they go, oh, this is actually pretty interesting. This is not only solving my problem, but it can solve a lot of my other problems. It gives me that output I want. And so then they download the software and go from there. So it's a lot of legwork on our end, right, to produce that content, to cold email people, to cold call people, set up demos. So it's really just getting in front of people. And then even at that, right, they still may not want to switch over, but it's a combination of word of mouth and sort of, aggressive, social media marketing and cold outreach.
I know with I'm just curious, this random way squirrel moment here, but there's SEO stuff, but now with AI, is there an optimization of getting AI to pull your data or anything like that, like to get to the front of AI to push what you're doing? Is that a thing at all?
That's a great question. I don't know the answer off the top of my head. I mean, I know that it scrapes, or, every so often it scrapes the internet, right? And scrapes all available information. And so, if you ask ChatGPT about CalcBook, it will know what we are and, and what our product is. But I don't know I don't know if there's SEO and AI and all that. I'm sure that, I'm sure there's something to it, but I don't know exactly what it is. Yeah. It's a good question,
I think you've given us some homework.
Yeah, now I'm interested. How do we?
Well, let us know what you find, because I want AI to tell people like, well, you want to get better at this, just listen to the Structural Engineering Podcast.
Exactly.
So how do you guys handle feature requests and decide what you're going to build next? I know you've got steel, concrete, and wood, I believe. How have you guys made those decisions?
Yeah, I mean, we have a big list that we keep. Every time a request comes in, right, we add it to the list and we kind of evaluate, a couple of things. We think about, okay, how how niche is this request? How useful is it to the greater engineering community? And then also how long does it take us to implement, right? We can get, and we have gotten, very niche requests on a very specific calculation, like, oh, I really want to have this property, or I really want to have the option to, turn this on or off or whatever. And it might take us an hour to program. And we're like, okay, we'll just do that real quick and get it done, right? Because that's a great experience for that customer or that potential customer, because they realize that we're responsive and we can, change things very quickly. But then other times we get very large requests or something that's going to take a lot of programming and framework, and we'll just kind of put that on the list and go, okay, this is not at the forefront right now, but this is a great idea, and we'll love to implement this as soon as we can.
Where do you see digital tools like CalcBook fitting in the future of structural engineering? And maybe as you develop the software, are you thinking about the direction structural engineering may be going and how you can lead that way?
Yeah, I mean, I think we can't talk about the future of anything without talking about AI, right? And this could be an entire podcast on its own. And actually, I just listened to your guys' podcast on the AI and AEC founder, and that was super interesting. And actually, I think that the intro to your guys' podcast on that one was pretty spot on, where I think sort of at least the current future of structural engineering is going to be with AI, in the sense that, creating spreadsheets and calculations and stuff like that, it's just not quite there yet. It can hallucinate way too easily and just does not give you the answers that you want. And on the other side of things, it is very good, in my opinion, at like QA QC work, or like helping develop proposals, or just today, actually, I was just kind of testing it and I got some steel shop drawings. And so I put in the IFC set, and then I put in the steel shop drawings, and I said, can you give me a list of things that it's missing? And it did a pretty good job, right? It identified, oh, they didn't identify the material type here. This is supposed to be galvanized. They didn't say it's galvanized. So I think stuff like that, where it's, less number crunching, so to speak, where there's a lot of very specific inputs and specific outputs you're looking for. I think that the audit QA QC process is a very realistic thing for AI in the current future. And then I think the other part of AI is sort of the adoption by structural engineers, right? It's like we talked about earlier, engineers are very, unwilling to adopt and move into new technologies a lot of the time. And so AI especially, I think, has a long way to go before engineers, are comfortable adopting it wholesale. So I think there's going to be, at least in our opinion, and might talk about this a little bit, of where we're going to go with CalcBook, is some sort of hybrid approach, right? Of where you still have access to, the calculations that you trust, and sort of the outputs and the inputs and all that sort of stuff, but implementing AI in a way that is sort of comfortable and is sort of not, imposing, and doesn't just take over the entire calculation process. So I think that there's definitely a hybrid that's going to happen, over the coming years. And then in the long term, I mean, I think AI will get there on the calculation side, but just not quite sure, when that will happen, and sort of how much it will actually do, and how much we'll be comfortable letting it do.
Yeah, I found it to be most useful to do it. Like the same questions I want to ask Eng tips, right? Like, where
Yeah.
can I find this in the code? Why does the lentil need to bear this long, this dimension or something like that? And then it tells me where in the code, and I can go to, the IBC or the TMS and find it. And beyond that, I work with people that are trying to find uses for it, and it's like, there's really not much more that we've been able to have great luck with, like what you brought up is comparing things, and it does a good job with that, or pulling up, asking it to read the specs and, verify things, and it does okay. But yeah, I find it as like the new age Eng tips, more or less. Like I go on there, I find who thinks here's the code section you should look at for this, and then I just go there.
Yeah, I mean, I think it's most beneficial right now, sort of like on the business, or like, the management side of things. It can be really helpful, like when I'm doing proposals or something like that, right? I can feed it the proposal, I can feed it our response, and I can say, am I missing anything? Did I address all of their questions? Or do we miss? Are there any red flags in our proposal that I should look at? And it's quite good. It finds things like, oh yeah, we missed that. Like we need to change this or whatever. So yeah, the business side of things, the management side of things, it's super good at right now. And then time will tell on the technical and calculation side of things.
I'm curious where you guys think that technology will change the way engineers document and share calculations, but also like as you're working with your developer, what are they thinking? Like, are they also pushing you of like, hey, the technology is moving this way. Here's how we could innovate. Here's how we could shift. Like, is that part of the relationship with your developer? Also,
Yeah, I mean, you know, a little bit. I mean, I think, from his perspective, it's hard for him to, from our developer's perspective, it's hard for him to give us a lot of insight on the structural engineering direction, right? Because he doesn't know really what's going on there. I mean, he knows a little bit, but we use AI, right? We use Cursor to develop, when we're programming, and so we are using AI to help us develop faster, right? And that has been a huge, advantage for us, especially, our developer has a full-time job as well, so me being able to go in there and make pretty significant changes to the program without his input has been huge, and so there is that aspect of it that he's definitely encouraged us to use, and he uses it as well, and so that is good. It can also be a little bit dangerous, obviously, but it is very helpful for sure to just use those tools when we're programming.
Right. Are there any other industries or technologies that you guys have used to help develop CalcBook, like some of the logic from other industries?
I mean, we're always taking in stuff from other programs we're using or websites we're on or apps or whatever. We'll take screenshots and we'll go, hey, like I really like the way this menu looks or this checkbox. Even little things, right? Or whatever. So we're always taking input from other technologies and other things that are outside of the engineering world. Sometimes I would say more so on like the UI UX front of things, where we really like to change, go, oh, this looks really nice, or like this flow is really good, and kind of go from there. We definitely think about what other programs have in the way of calculations and what we should be thinking about including, so we kind of do that as well.
I think we also got inspired by is a better word than plagiarized, but definitely got inspired by a lot of different stuff online when we did like web design also. Like again, we're not marketers, we're not salespeople, we're also not like graphic designers or website designers. So I think we really needed to use outside inspiration as a crutch when doing that stuff. Again, yeah, so out of our depth on some of that stuff, it feels like. So yeah.
so to kind of wrap us up and kind of reflect on everything, what would you say is one thing you wish you knew before starting CalcBook?
I think it would have been nice to know that it's not going to be like hot off the presses right when we hit the release button. I think our expectations were way too high with that. And I think also, yeah, we touched on it before, but also knowing like the fact that it's not going to be hot off the presses and getting downloaded a bunch meant that we could have given some slack to ourselves in the first version 1.0 iteration of what sort of features we needed to include. I think that was the biggest learning curve for me. And then, yeah, I mean, like, it's a lot of work. You got to be self-motivated, especially when it's a side job and it's nights and weekends, and no one's going to be there to kick you in the butt except maybe Peter and I doing it to each other. So I think we learned along the way how much work it was, and maybe that was good not to know when we started. It could have dissuaded us from even getting into it. I mean, in hindsight, now I'm glad that we did, but I mean, it's been, I don't know, 7 years or something like that since inception, and I don't know. I wouldn't have been surprised when we started if it just had fizzled out at some point along the way, for sure.
And I mean, it definitely did like fizzle out a few times here and there. There was times like, after the prototype, we built it, like, okay, well now, now what do we do with this? And kind of nothing would happen. And then we would kind of set a goal for ourselves and then do that. So I think it just, takes a lot of dedication, and I wouldn't have been able to do it on my own for sure. And so like sometimes I'd be working heavy on it and Nick wouldn't, and then Nick would be on it and I wouldn't. And so being able to have a really, really good partner. I mean, that's the other thing too, is picking your partners wisely, right? I spent a lot of time with Nick over the last years, right? And putting this together. And so, having somebody that you respect and you want to work with and you trust their input, and, you're not going to take offense to them telling you, I don't like this, or we shouldn't do it this way, and vice versa. I think that's super important. And then the other thing I was just going to mention is, this happened more recently, but I think it also applies to, before starting, is I had a family friend who's sort of in the marketing business world, tell me, he was like, nobody knows who you are. Nobody knows who CalcBook is. Nobody knows what CalcBook is, right? You have to go out there and tell everybody, tell the world what you do, why you're better than everybody else, and why, people should download and pay for your product. And so I think, having that earlier on, or having that mentality earlier on, I think would have helped us, and just kind of putting that grind more in the marketing and outreach side, and really thinking about that more earlier on, I think would have helped us quite a bit.
Yeah. One other thing, when we were having a meeting with another guy who's helped us with some advising us on some marketing stuff recently, we're like trying to, ramp up. We're growing and have been growing basically since launch, but we'd like to accelerate, of course. I mean, who wouldn't? And I think, when we thought of the business as a concept, it's like, yeah, then we'll just make the program, and then like licenses will sell themselves, and then we just like cash paychecks and like, go on vacation or whatever. And this guy who's helping us like sort of build our growth strategy and marketing strategy, basically, like at the end of the meeting, he's like, so yeah, you basically need to keep on working. Like, and it was just like, it's so obvious when you hear it out loud, but it's like, yeah, of course. Like, you got to keep banging your head against the wall. You got to keep calling people and emailing people and making social media posts and like getting out there. I mean, that's part of why we're doing this podcast also, is like, you're just banging your head against the wall and trying to get people to even know that you exist. And I mean, there's no free lunch, and it was naive to think that there even could be. But it's been super fun and a super nice, learning journey, and different than the normal structural engineering grind, which I've appreciated. And I think, Peter and I have like really expanded our skill sets along the way, both technically with coding and also with all the design and marketing and social media and all that stuff. So I don't think we have any regrets, but yeah, it's still work, which
I don't lie to
that's
the
life.
generation out there. Everything the internet says is you're entrepreneurs, you drive Lambos, and you fly in private jets. So I don't know what you're talking about, this work thing.
All with the drop shipping from your couch, right?
Yeah.
There you go. So with all of that, how do you guys end up balancing running this, this company, doing your day jobs as engineers, and having a personal life? How do you guys kind of do all of that at once?
Yeah, I mean, it's a balance, right? I mean, I think we're recording this podcast at it's 8 p.m. for me, it's whatever 5 a.m. for Nick, it's 9 p.m. for you guys. So I mean, this is a perfect example of how we balance things, right? It has to be a passion, right? We're doing this on nights and weekends, and you have to kind of be willing to do that, and there's going to be sacrifice for that. And having a patient wife or partner, right? That's huge as well. And Zach, you and I were talking about, we both have under 2-year-olds, and so having someone to help with that, and kind of take that balance and support you in the passion. And so, I'm lucky enough, and Nick's lucky enough to have that we have that support. And, it's for the first year or two, we were meeting every Sunday morning, like almost 1 hour, 2 hours every Sunday morning, the three of us. and we had these 2-week sprints that we were doing to get, all these different things done. And we just kind of kept on this routine. It wasn't an option, right? Everybody was relying on you to do these things. And so it was just all these nights and weekends, and just kind of trying to maintain this pace, and keep everything moving in the right direction. So it's a balance, lots of sacrifices with not going out or, not doing things on the weekends because I got a program or whatever. Yeah, it's sort of a constant, it's a lot harder now with a kid and all that, but we keep doing it. So
It's also a lot of communication in advance, I would say, is important. Whether it's to your, wife, or from me to Peter, or, just sort of keeping a schedule, holding yourself accountable to that schedule, and keeping the people in your life informed of that, and saying, hey, we got to, if my wife and I are out for the weekend and I tell her we got to be home by 5 p.m. on Sunday because I have a CalcBook meeting, and, communicating that in advance. And yeah, I think both Peter and my wives probably deserve a shout out because they've probably dealt with a lot of having to be patient over the years and our schedules. So that definitely helps. But yeah, from our side, I think, communicating it as far in advance and setting the expectation that I have this obligation I need to meet, and sticking to that.
Yeah, it's a very good point. Well, the final question here to wrap us up. What's next for CalcBook? Any exciting updates or directions you guys can share?
Yeah, I mean, in the immediate future, we are nearing completion on a retaining wall module, which we're really excited about. We've gotten a lot of requests for that one, and we've got some new graphics as well coming out with that. So some dynamically updating images with all your soil pressures and loads and all this sort of stuff. And so that's gonna, that interface is gonna start to trickle in through the rest of the program as well. So we're releasing it with the retaining wall module, and then we'll sort of start applying the new graphics and stuff and the new layout to the rest of CalcBook. So we're really excited about that one. Like I said, a lot of requests for that. So we're pretty pumped that that's coming out pretty soon here. And then another thing we are also doing like a UI UX makeover, which is sort of part of this new graphics thing. And so we have this UI V2 coming out probably in the next couple of months, which will be great. It's still relatively the same when we first built this. And so we've had all these ideas of updates we wanted to make to the user interface. So that will be really exciting. And then in the long term, right, AI, we have some ideas. We don't want to share too much about how that's going to be implemented, but we know that AI is here and it's going to make its way into engineering, and we think that we have a great platform to implement it. So we're definitely going to be putting it into CalcBook in some way, and hopefully that will be coming out soon. So we're excited about that as well.
Well, fantastic. Well, Nick, Peter, thank you so much for joining us on the podcast. We really enjoyed this conversation and excited to share this with our audience on, how to develop a business and everything you guys have gone through. So thank you so much.
Yeah, thank you guys.
Yeah, thanks for having us on.